Okay, let's go ahead and get started. I'd like to thank everyone who's joining us today. Today's webinar is Fluent Bit version 1.5. I'm Julius Rosenthal. I'll be moderating today's webinar. We'd like to thank our presenters today. Eduardo Silva, Principal Engineer at ARM Treasure Data, Masoud Koleini, Staff Research Software Engineer at ARM, and Wesley Pettit, Software Developer Engineer at AWS. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can at the end of the presentation. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please note that the recording and slides will be up later today on the CNCF webinar page. And with that, we'll hand it over to our presenters.
Thank you. Well, welcome everybody. My name is Eduardo Silva, one of the maintainers of the Fluent Bit project. And today, together with Wesley and Masoud, who are maintainers from different subsystems of the project, we will share some news about this new release, but also for newcomers or for new people that is just learning about this ecosystem of logging. We will start with a little introduction. Then we will start with the news about Fluent Bit, how our experience migrating original plugins written in Go to C language, and finally an introduction to one of the stream processing capabilities. So this webinar will be a little bit more than just the release, but so we aim to share more knowledge about different components. So Fluent Bit in general aims to solve all the problem that is generated when we want to achieve data analysis, right? If we want to achieve data analysis, we have to collect all the data from hardware, software, and deliver this to a central place. And this gets more problems when data start to scaling up because we get performance penalties. And the data challenges is that data comes from different formats, from different entry points like TCP, UDP, file system, or journal-D. So how do we accomplish this? And if you think about distributed environments such as Kubernetes, you can think that every pod, for example, has one application or one more container. Every single container is generating their own login information. So if you are on this cloud native era, how do you solve this data analysis concentrating all the information together, which is a major challenge that we have. In addition, besides centralization, is about to deal with different data formats. As you can see, for example, Apache Logs comes with an unstructured format, same thing for MySQL and JSON maps and so on. So one of the goals also of a log processor tool like Fluent Bit or Fluentd is the ability to convert this into a structured way and have the notion of key and values and with an internal representation in binary format. So before the data analysis, we need to collect this data from different sources, convert this data, and also there's many cases where we want to enrich data. We can say, hey, this data is coming from a different node, a specific pod, or this specific instance. So besides just to have the message that is involved, we also want to add some context to it to say, hey, this is coming from this host, this IP address, and so on. And this is when comes Fluent Bit, which is a tool that aims to solve all these data collection problems and data processing problems. I have to say that Fluent Bit, it's a CNCF sub-project under the umbrella of Fluentd, one of the graduated projects of the CNCF. And Fluent Bit started in 2015. Its origins was, at the beginning, it was created for lightweight environments for embedded Linux and quickly evolved for the cloud native space. So, and with this, we always think that we needed to have something that was very lightweight and really fast and very efficient from a memory and CPU perspective. That's why it was written in C language. It's very optimized. If you are doing nothing with Fluent Bit, like a needle instance, it barely will use 600 kilobytes. And doing it pluggable architecture, we provide more than 60 plugins to deal with different source of data, data formats, and also to, with the ability to ship this data out to different destinations. And of course, we provide built-in security, TLS, and networking I/O. Fluent Bit can be considered like a data pipeline when in one entry point on the left, we have all the inputs of data, we have all the parsing, filtering, buffering capabilities, and finally, the final step, which is the ability to route this data to different destinations. With destination, it can be a database, a cloud service, or anything where you aim to store your data together. If we think about Kubernetes use case, which is a most complex scenario, for example, you can think that in your node you have pods, and the pods are writing all the login information to the file system. So how do you solve this with Fluent Bit? Basically, you deploy, one of the use cases is that you can deploy Fluent Bit as a daemon set for this kind of a generic scenario where a daemon set is just a pod that runs on every node. It's able to read all your logs from all your containers, then talk to the API server to retrieve all the metadata that is associated with that pod to finally be able to send the data out to a central place like your database or cloud service. This is one of the deployments model that we have for Fluent Bit, but also you can use it as a sidecar, which is a very common use case used by many customers and companies. So here's where we talk about now about the journey of Fluent Bit. You know, Fluent Bit was started about 5 years ago, and we're reaching our version 1.5. And there's a couple of improvements on how do we deal with networking sessions. When you deploy a tool that leads and talk to different network services, we face many issues. You can have network outage, unresponsive services, and the only thing that we can do from a client perspective is to be able to provide setup to define specific behaviors to work around or perform certain actions when that happens. So on this version, we are introducing everything about connect timeouts, meaning I'm trying to connect to this endpoint, but that endpoint is unresponsive. How much time should we wait? The ability to define a custom source address, or for big servers that has a ton of network cards, say, hey, please connect using this specific network interface. And also the ability to reuse the TCP connections and TLS session, which is mostly called keep alive. And this is keep alive, it's about the concept of keep the socket connection open after one successful delivery of data has been done. And also we support the keep alive idle timeouts. One of the features that people were very interested in, and also surprisingly for us, for the maintainer, has been that people's asking a lot of support for Windows environments. Well, Fluent Bit, since last month, we have integrated Windows support at different phases. And on this version, right now, we provide a full Windows service support, so you can manage Fluent Bit as a Windows service. Now, the plugin that is able to collect Windows event logs, which is like the mechanism for the Windows engine, now we are able to fully encode all these messages UTF-8. And also, we have full support for Kubernetes on Windows. I know that for many people, this is a surprise, and for us, it is too. But yeah, you can just Fluent Bit on Windows and also manage all your Windows pod login data with Fluent Bit without any problem. Also, the community has contributed many ways on how to improve the experience from an operational perspective with Fluent Bit. So right now with the repository and documentation, we are shipping out some Grafana dashboards that can be really useful for you to just connect the dots between all your login pipeline, monitor how the data is flowing, data rates, which is a really important information. In addition, the storage metrics, the whole metrics has been extended. We used to have metrics for the pipeline, like how much data is being generated by this input plugin, how many bytes, how many retries we are facing the output side. But we got many use cases that say, hey, we want to know how is internal buffering mechanism, how is the data flowing. I need to shut down Fluent Bit, but I need to know if there's any data in the queue being processed. Okay, so this is where it introduced the new storage metrics endpoint, which basically just push out a JSON map which have different information, like how's the storage layer, if the buffers in memory, how many, the buffers in the file system, if the buffers in the file system are also up in memory. And from the input side, we can know if any plugin is ingesting too much data, is over limit, or we can get more granular information about this. And I think that this is a huge improvement from an operational perspective. Another big news on this is the ability of new enterprise connectors. And I want to say, reinforce that enterprise connector aims to say connectors that are contributed by or that we work in joint with them to create for specific services and for these companies, but also for their own customers. So on this new version, we're officially launching Amazon support, also the support for the Amazon Elasticsearch service. So for the Elasticsearch database that is hosted by Amazon, we have full support with that. Wesley will talk more about it, same as for the Amazon CloudWatch service. And now we also have two new connectors for the login services provided by LogDNA and New Relic. And actually, we are very pleased to have been working with Amazon, and LogDNA, New Relic, Google, Sumologic, and others companies on this period. Google has been working really hard also on improving our own Google Stackdriver connector. So we built an initial Stackdriver connector that has been used by the many customers, but also Google started contributed back a few months ago. So now the Stackdriver connector is trying to have the same parity of features than the Fluentd connector for Stackdriver. So this is really good news for everybody who relies on Google Cloud services. And some project status. As you can see, the adoption of Fluent Bit, we have just a fraction of visibility about who's using it or the number of deployments, but at least from the public perspective from our Docker Hub repository, just on the half of this year, we're reaching more than 100 million deployments. So barely every day we have more than 500,000, and the stats keeps continue growing. That means that Fluent Bit is deployed every day that amount of time, but also the same node that was created was destroyed. Maybe that node was created again. It's deploying Fluent Bit again. So I would say that this is like a cumulative stats and not unique stats. But in general, we can see the trend that adoption of the project is growing a lot. And in the enterprise, we can say that most of the biggest companies are using Fluent Bit right now. I think that as a team, we are pretty of it. So like logistic companies like, for example, Lyft, Transit, we have the cloud providers like AWS, Google Cloud, Bankside Cloud. We have Walmart using Fluent Bit, now New Relic, Giant Swarm, Humio. So for us, having all these companies adopting technology is really important, because also it means that the ecosystem of Fluentd is also growing and passing a part to the Fluent Bit ecosystem. So, and working with companies for us is a major priority, because we know that the kind of use cases and challenges that they face every month is kind of new in performance, in deployment modes, configuration, and so on. So now I'm going to hand over the presentation to Wesley, who will talk about the AWS plugins and how they were migrated to the Fluent Bit core.
Awesome. All right, let's do this. Hello, I'm Wesley. I am the AWS maintainer of Fluent Bit. I joined the project this year, so I'm fairly new. but I've done a good amount of work, and I'm going to talk about that. So last year, I launched AWS for Fluent Bit, which had a set of plugins in Golang for Amazon. So there's Amazon CloudWatch Logs, Kinesis Firehose, and Kinesis Data Streams. Those were launched in 2019. So the reason why we wrote the plugins in Go is, one is because Golang supported very fast development. It helped us launch an integration with Fluent Bit very quickly, but also there was an AWS SDK in Go. So AWS has its own authentication mechanisms. It's called SigV4 signing, which is the auth algorithm that AWS uses for AWS services for our APIs. And then there are many sources for credentials depending upon where you are running in AWS. And these mechanisms are all supported by the standard AWS SDKs. There was not an AWS SDK in C that I could use for Fluent Bit, and so that's why I was unable to contribute to the core of Fluent Bit. However, I've now fixed that. So I took a long vacation in the winter, and I spent most of my vacation actually building a custom sort of low-level AWS SDK in Fluent Bit that worked with its built-in HTTP client and concurrency features. This is showing a screenshot from part of the final pull request, which ended up being over 6,000 lines of code. It was quite big, but I'm very proud that it's finally done. And it's now launched in 1.5. So with this library, we're able to make requests to AWS inside the core of Fluent Bit. So the first thing that we did with that is we enabled Amazon Elasticsearch service support. So there was already, of course, a Fluent Bit plugin for the Elasticsearch project, but it did not support the Amazon hosted version of Elasticsearch because that version uses AWS authentication. So with this new library, you can enable AWS authentication. So there are a couple new fields. So one key thing to point out, first of all, the host, when you use Amazon Elasticsearch, you do not include the transport protocol, don't include the HTTPS. That's one thing that got me confused when I first started testing it out. The port is almost always port 443. And then you have to add these fields, AWS auth, turn that on, and then you have to add your AWS region. You also want to enable TLS, of course. Then you optionally also have this parameter called AWS role ARN, which lets you specify an AWS IAM role that can be assumed to make calls to Elasticsearch. So that will use STS assume role. If you're familiar with AWS, that should all make sense. If not, we have some documentation on this that you can go read afterwards to understand. Also, so as I said, last year we launched a CloudWatch log support in Fluent Bit through an external Golang plugin. This year, with 1.5, as Eduardo mentioned, I added natively in Fluent Bit in C CloudWatch log support. So the plugin name is CloudWatch_logs. The old plugin was just called CloudWatch, but besides the change in the name of the plugin, it supports all of the same parameters, and it works exactly the same way. So try that out. It's very easy to migrate. So what I'm quite excited about is the performance improvement that we've seen from switching to Go to C. So here's some benchmarks that I ran. This is tailing log files and then sending them to CloudWatch. The CPU usage is a good bit less for the new core plugin in C, but also I think more importantly, the max throughput that the core plugin can achieve is significantly higher. This is something that I'm still working on quantifying. I don't actually have hard numbers on it yet. I just have like anecdotal evidence that it's definitely a lot higher. Eduardo and I are speaking again at the virtual KubeCon, which is happening in August. And hopefully by then, if I have time, I will find a way to actually measure and quantify the performance and throughput difference between the two plugins. The existing Golang plugin had sufficient performance for essentially all customers that we had, but it's still nice to have higher performance for any new higher performance use cases that might come up. Then this is showing the memory usage. The memory usage is really where you see a much larger difference because, of course, Golang is a garbage collected language. The AWS SDK for Go also is not a particularly efficient library in general. So the difference, you can see a 3 to 4x difference in memory usage between the old plugin and the new plugin, where the new plugin will be like 25% of the memory. So you can see here in this graph that even at 20,000 log lines per second, that's tailing 10 log files, each 2,000 log lines per second, we're only using about 40 megabytes of memory, which is really impressive. For comparison, compared to, so before I switched to Fluent Bit, I was working with Fluentd. Fluentd, compared to the Fluent Bit Golang plugins, that was like about a 5 to 7x performance improvement. So if you add an extra 3x performance improvement in memory with the C, that's like a 20 to 30 times improvement over Fluentd, which is just really insane. So we're very proud of that. So the long-term plan is that I'm going to work on hopefully rewriting all of the original Golang plugins in C and contribute them to the core of Fluent Bit. Then we can deprecate the Go plugins. And the idea is maybe what we can do is once we have the C plugins at full parity with the Go plugins, we can remove the Go plugins and alias their names in Fluent Bit core so that basically you don't have to migrate your configuration. It just works with the C plugins starting in some release of Fluent Bit. The timeline on that is very uncertain, and I should be very clear that this does not represent any sort of a hard commitment from myself or from AWS as to exactly what we will do, but it's definitely something that I'm thinking about. So what am I working on now? So right now I'm actively working on supporting outputting logs to Amazon S3. There's a GitHub issue on the Fluent Bit core repo. If you have thoughts or ideas on how that should work, I've already posted some information there on building a prototype and on how the plugin will work and the options that it might have, some ideas. So go check that out if you're interested in sending logs to S3. So here's possibly what the config might look like for S3. What the plan is to be able to do set a file size that you want in S3. So like you can decide you want a 250 megabyte files in S3. So it will upload to the file logs till it reaches that size and then truncate the file and move to a new file. The plan is also to support kind of like a timeout. So you could say create a file in S3 once per hour. But part of the goal is that part of my idea is that I'm going to use the multi-part upload API for S3, which enables you to upload large files in small chunks that can be uploaded over time. So that should enable Fluent Bit to basically, as it gets logs, to upload them to S3 in parts. And then once it's done uploading the right amount of logs, it can concatenate them together with the S3 API and create a file. That way you'll get nice large files in S3 created over time, but Fluent Bit will not be buffering very much data locally, which means that you're not at very much risk of losing data if Fluent Bit quits, or if your instance goes down that you're running Fluent Bit on, or anything like that, because it's sending the data off to S3 basically as quickly as it gets it. It's streaming it basically. That's the goal. I haven't actually gotten it working yet, so we'll see. But probably, I think by the time we do the talk in KubeCon next month, I should hopefully have the plugin mostly fully working by then. The goal is to launch it in September in Fluent Bit 1.6. So finally, if you're an AWS user and you want to get help with using Fluent Bit, so here's your options. So sometimes people find my email and email me or message me on Twitter. To be honest, that's not the best way to get in touch, because I don't necessarily reply to those very, very quickly. You can open an issue or comment on an issue in a Fluent Bit core repo and mention my GitHub name, which is Pettit Wesley. I watch that and I will respond. The best way is actually, though, to go to the AWS for Fluent Bit repo, which is our distribution of Fluent Bit. The reason is because there are a couple other folks who I've been training to understand Fluent Bit, and so we all watch that repo and answer questions there. I prefer that because it's nicer for me, because I can kind of distribute the load of answering questions to multiple people. Lately, we've definitely felt that it looks like Fluent Bit is really becoming popular because the number of questions that we've been getting have increased significantly. Finally, if you're interested in becoming a Fluent Bit contributor yourself, I wrote a contributing sort of guide, like not like as a style guide, but a guide of like, if you're a beginner, how to understand the code and kind of like how to write the code. It's definitely a beginner tutorial. It's not going to give you enough to like write some of the more complicated stuff that Eduardo or myself have written, but it should get you enough to like start. You can start writing a bit of code, you know, try to start with smaller features and then work your way up if you want to contribute to Fluent Bit. That's it. And with that, I'm going to turn it over to Masoud.
Hello, everyone. This is Masoud Koleini, and I'm the maintainer of stream processor for Fluent Bit. So if some of you know what is stream processing, it's actually the ability to perform data processing while it is still in motion. In general, what you do with stream processing is that you can apply computations on the stream of data in real time that is coming from your devices. For stream processing, we have events, which are records that are emitted by applications, services, or hardware, and you receive them through your input plugins. And events are structured messages. They're composed of timestamp. Every event has a timestamp, which specifies the time that event was created, and the message, which is actually the data inside the record. What we need from a stream processor? What are the goals? In general, we want it to be fast and lightweight data processing. We want there to be no tables, and we want there to be no indexing. And it has to have an easy-to-use programming model. For example, what you can think of is that you can think of Fluent Bit as a kind of data collector, buffer, and distributor. And you can think that, okay, so what if I want to do some computations while I'm receiving data from one or more of input plugins? And if I want to do the computations, not to send them out, and before sending them out, and only send them out when I need that, then stream processing is possibly one of the major tools that you can use in Fluent Bit. But how we can do that? And how in general a stream processor works? Stream processors in general can receive events or records from hardware or software that are attached to them. They can apply real-time data analysis, and then they can send the result out to a data collector or event collector. So in general, the stream processor receives structured events or records, exposes a query language, which has key selection, filtering, aggregation functions, and event routing, and it does the processing in memory. However, when you want to do some stream processing on the edge with the current on-the-shelf stream processors, what you do is that you have log event collectors on the edge, and then it sends everything, all the records, to the cloud, to the stream processor, which can be Spark SQL, which can be Apache Flink, which can be Kafka Key SQL, and what they do is that they do all the analysis in the cloud and send the result again back to some servers like some data collectors or log collectors or metric collectors. However, what you want to do is that stream processing on the edge. This is what we saw, like current stream processors are working on cloud. And what we currently have is that we have added a stream processor to Fluent Bit core, so you can do all the processings that you want, all the computations that you want on the edge before sending huge number of data out to the cloud and do cloud-side log or data analysis for the data that you are receiving from different hardware and software. What are the reasons? In general, what stream processing on the edge can do for you is that it offloads computations from servers to data collectors. Just assume that you have thousands of data collectors, and many of them may have free resources like CPU and memory available. And if you can upload just even a small piece of calculations to your edge devices, actually you're paying a lot less for cloud computations. You're paying a lot less for your traffic flow between edge devices and cloud, and you will be actually very fast. It also only sends required data to cloud. So you may do computations, you say that, okay, so if the computations had this result, don't send data to cloud. So you can decide on sending the data that you want to cloud. Like many other stream processors, Fluent Bit also uses declarative SQL-like language to express the computations. If you guys are familiar with SQL, you know that it is a high-level declarative language that you can easily specify many kind of computations in that on the records and data, and it is easy to understand, easy to write. So it is very useful if our stream processor or any stream processor uses a SQL-like language to define the computations that they want to do on the edge. It is integrated in Fluent Bit core, so it is very fast, memory, and CPU efficient. This is the syntax. This is a simplified syntax, we can say. We will see that in demo later. You can write create a stream name, as, and now you can have a select statement similar to SQL, where you can write select. The result statement is the same terms as SQL. Like you can say select the average of memory, select the minimum CPU usage, select the minimum of this field in the record, and you have from, and SQL you have from a table, and here you have from a different input plugin or another stream. And then, as you might know as well, when we do computations on the streams, we need to have a window that we do apply the computations on. Like we can have a window that we put all the events from last, for example, 30 seconds in. We apply computations, and then we throw everything away. We wait for the window to be filled in. We call this window tumbling window. We can have another window that some of you may know that as moving window, where this window is called hopping here, and we can say that there's a hopping window of size 30 seconds, and it advances by, for example, 1 second. So every 1 second, we throw away the old data from the first 1 second and put back the new data for the coming 1 second that we were in. This is called window hopping. We can have where condition where we can filter the required records. And important thing is that we can have group by, when we can group the records by specific fields and apply calculations on the groups. We support functionalities here. We have many more functionalities, but some of the more important ones are you can apply average on the key, count, minimum, maximum, and sum, similar to aggregation functions in conventional SQL. We can have time functions, like we can add now, which is the current time or Unix timestamp to the record. And we're adding more complicated functions. Like if some of you are familiar with time series functions like a forecasting, which is a linear regression or simple linear regression, you can apply a forecasting to your stream, and you can say that, okay, so we have memory, we are getting memory from the input memory plugin, and give me the forecast of memory usage in the next 100 seconds. So these time series functions can do that. For example, time series underline forecast underline R is the reverse of that. You say that, tell me when in future my memory usage will pass a certain amount, so I know that I will be in the safe range of memory usage. I will show that to you in the demo, how we can use in general the stream processing and these time series functionalities. One nice thing is that for stream processing, we support subkeys. Let's say that you have nested JSON. You can apply those computations on nested JSONs using like what you have down the page, key, square brackets, subkey 1, square brackets, subkey 2, if you have a nested JSON of depth 2. A simple example. You can write a stream processing rule like this, or task, we say. Create a stream with the name of results, wait, tag is results, similar to the tag that you define for the input plugins. You can tag your stream as, and now you have your select statement. Select average of CPU from CPU stream, that is actually your input CPU plugin, with a tumbling window of size 60 seconds. Simple. So you wrote a full functioning computation of taking an average of a specific field of a record using just one line of SQL statement. Let's go for a demo. And if you guys have any problem in seeing my screen, please write that in the chat window so I can fix it. Okay. I'm hoping that everyone can see my screens. Here, I'm running Fluent Bit. So we need a configuration file. This is a configuration file for the demo. I'm hoping that you guys are familiar with writing configuration file for Fluent Bit. Here we say that we have the service section, which says, okay, so flash output every 1 second, log level is info, HTTP server on, plugin files is this. You need to add the path of your stream file. So streams file is actually the name of the file that you are writing your stream processing tasks inside. That's it. You don't need to do anything else here in the config file. You define, here we have an input plugin memory that we are reading data from this input plugin, alias memory, tag memory, which will use that in the stream processor. And what I'm doing here is I'm sending the result of forecast. Let's say here, we say that I have match forecast star. That means that send the result of the forecast, send the result of any input or stream processor that has a tag forecast star to the InfluxDB. InfluxDB is a time series database, which I'm using that in order to visualize the result of these stream processing tasks to you. In addition, I'm writing everything else to std out in order to make sure everything is working.
Hey,
okay.
Masoud, can you increase your font size, please?
Yeah.
Thank
Is
you.
it good? Sure. Okay, so I hope that, so at least you could see what I was saying. So I will go to the next step. Now we have defined the streams file. Let's see what is inside the streams file. Okay. This is the way that you write a stream processor tasks. You start with the section stream task, name of the task, forecast, and you define an exec, which is actually defines the SQL processing syntax, similar to what I mentioned in the slides. You start with create a stream forecast, the name of the stream, as now here your select statement, You can say, give me the average of, as the result, give me the average of memory used and the time series forecast. Give me the forecast where the input is record time and the memory used for the next 100 seconds. Tell me how much the memory I will use in the next 100 seconds. And you say as forecast. That means that name the output record as forecast. From memory, a stream memory, which is actually our memory input plugin, use the hopping window or a sliding window of size 15 seconds and advance it by 1 second. I've added another stream processing task here just for the sake of demo. The forecast value may not be very smooth, may go up and down a lot. So what I'm doing is I create another task called forecast average, and I say create a stream forecast average as, now select the average of forecast. What does a stream processor do is that it reads from the forecast stream. And the nice thing here is that every task in a stream processor can be seen as an input. So we can cascade many stream processing tasks together. So I'm reading from a forecast memory and take an average on the forecast value. Again, I define a hopping window of size 15 seconds, advanced by 1 second. Okay, nice. So in almost 2 lines, we have defined 2 stream processing tasks with 2 almost complicated functionalities. Now let's see how it works. I started running it. So what I do is that, as you may know, I run Fluent Bit and pass the configuration file demo.conf. For the next first 15 seconds, because the window of the stream processor is filled up yet, you can see just the output of the memory plugin. And around now, you should be able to see the forecasted value. Yes, here it is. So I highlight it. So it says that, oh, memory usage is 3.4 gigabytes and the forecast is 3.4 gigabytes. So it says that I don't see any reason that in future, in the next 100 seconds, the memory usage will be changed because we're actually not running a huge number of processes on the local machine. So what I'm doing here as well, I'm hoping that you can see my my screen, and you can see this graph. It is a Grafana dashboard that actually is connected to the InfluxDB, and it is showing the average memory and memory usage. You can simply see just one line because they're overlapping, because the memory usage and the forecast is almost the same. It says that the yellow line is the average memory usage, which is 3.4 gigabytes. And the forecast is almost the same. It says that I don't see any reason that, I don't see any trend of change in the memory that shows that in the future we'll use more memory. Now let's do a trick. Let's run a process that starts consuming memory of my machine. And let's see what will happen. Wait for the refresh. And possibly you're seeing a green line going up, where the green line showing the forecast of memory usage. In every time, the yellow line says that, look, the average memory use, the memory that is used currently is 3.4, but in the next 100 seconds, we will use 3.7. And look at here, I defined a line that is called alert. That means that whenever the forecast passed 4 gigabytes, send an alert, create an alert, send an email to the admin or to operator or a phone call or whatever before we actually get to that point. That means that something is going wrong with the machine. So we can see that the green line is forecast that our stream processor is calculating, and the yellow line is the actual memory usage at the current time. And now the green line passed the alert, and you can see that, no, it gets red. Now let me terminate the memory consumption and see what will happen. Yes, yellow line drops a bit, but green line drops a lot more because it sees the trend of reduction in the yellow line and it thinks that, oh, we are going to consume a lot less memory. But after some time, when things get settled, they again get back to normal and everything will be a lot better. So forecast will be again the same as the actual memory usage if something is not running your machine. Okay, I can see there are some questions. I will ask the questions after this because it's almost the end. Okay, let me go back to slides. So I think we are almost done with the demo and we are almost done with the stream processing presentation. But possibly the final thing that you can think of is that it is not bad to not to see Fluent Bit as a data collector, buffer, and router. You can see Fluent Bit in general and stream processing specifically as a way that you can do a lot more computations on your data that is coming to the Fluent Bit without sending that out to cloud. You can do loads of things with Fluent Bit. You can do machine learning on the edge. You can do many different calculations, and this can do a lot for you in your projects. Thank you.
Thanks, Masoud. So I think that we're going to, on the last part of the webinar, and now we are going to jump into the Q&A. So please, if you're in the chat or you have some questions or you would like to ask something to the maintainers, this is the right time for it. Yes, I'm not sure if they can unmute themselves or needs to be through the chat.
Yeah, so everybody feel free to ask your questions in the Q&A and I'll go ahead and ask them. So could you guys, this is from Jindong, could you elaborate a bit more on the hopping parameter 15 second and 1 second?
That's a question for Masoud.
Yes. So this is called, so the hopping window works like this. It creates a window of size 15 seconds. That means that it buffers all the data that is coming for 15 seconds. And now what it does is that in every second, it throws away the oldest data from the first 1 second and puts into a queue, it's like a queue, and puts back into the window the new data that is gathered for the last 1 second. That means that in every 1 second, it throws away the oldest 1 second data and adds the newest 1 second data to the window. And what it does is that means that it still keeps some of the data that is arrived in the last 15 seconds. I mean that it keeps the data from the last 14 seconds and then adds 1 second data. In the next 1 second, it keeps the data from the last 14 seconds and adds 1 second of data. So that means that the data size, the window size always shows the last 15 seconds. Did it clear that for you?
Yeah, it looks like it was clear. All right, does anybody else have any questions? I guess we have one. Can you guys elaborate on the name Fluent?
Okay, I'm going to elaborate on that. This is by what it was sold by the creator of Fluentd, okay, when it's part of the story of the company. So when they created the treasure data at the beginning, this first Hadoop as a service, that's how it started. And they needed to have a tool to ingest data into this new cloud platform. But it aimed to collect data from different places, from different languages, because as you can see in the Fluentd ecosystem, we have different SDKs. So this new tool needs to be fluent enough to understand different formats, fluent enough to be connected with different languages, and that's why the ecosystem was called Fluent. And then the project was named Fluentd as a daemon. You know, most of the Unix services ends with D, and that's why the Fluent name. And well, Fluent Bit was created in 2015, I would say 4 years after Fluentd. So we put it the bit part of the name because it aims to be like a lightweight option at that time for embedded and constrained devices. But we always keep it as a Fluent ecosystem.
Great. Ali has a question. Can you explain a bit about the forecasting part and how the computation is done?
So actually this time series forecast is a simple linear regression, which tries to estimate the trend with the line. And based on that, it calculates when in future the line will reach a specific value, which is called forecast. So if you want to read more about it, so you can just search simple linear regression. And this is actually the way it works.
Okay, great. Last call for questions. Okay, oh, here we go. Can plugins written in Rust be integrated with Fluent Bit?
At the moment, the only integration that we have to write plugins, of course, are C language. Fluent Bit is written in C language. You can write output plugins in addition to C in Golang, right? Or you can write filters in Lua. We don't have bindings for Rust. I know that AWS was investigating if it was good or not enough to invest into integrate Rust connectors. But one of the major, I would say, integration problems was that, for example, if you wanted to write an output connector, you had to re-implement or reuse external components to replace internal things of Fluent Bit. Like, for example, Network IO, HTTP client, because it's like in Fluent Bit, everything is done handcrafted, right? And it's very optimized for concurrency. So putting an external component in Rust sometimes is not as straightforward because you need to rely mostly on Rust API and their own libraries for connectivity or for other things. And I think that this is not a challenge that has been faced just by Rust, but I think that it's pretty much similar to what happened to Golang. So if you write an extension for Fluent Bit in Golang, you face pretty much the same issue. You are relying on your Golang APIs, right? So you get the advantage as you write that thing in an upper level language, but you lose a bit of optimization, you lose performance because you are not using the internal code that is designed to work with a special concurrency mechanism. I know that also there's other projects, for example, in the ecosystem, on the CNCF ecosystem, that they are investigating the same thing. This is not just about Rust, but other languages. For example, Envoy, who's an Envoy proxy, they are evaluating how can be integrate plugins in Rust for filters. But they're pretty much, if you can see the open discussion on GitHub, they're pretty much evaluating the same thing. We will end up rewriting a lot of components just to be, because it's Rust, right? So I think that at the moment, for the original question, no, there's no plans to integrate Rust. because I think that for Fluent Bit project, there's not enough benefits at the moment, and mostly from an integration perspective and challenges.
I'll add a little bit to that.
Sure.
So yeah, at AWS, we investigated the idea of working with Fluent Bit and Rust. We of course started with Go, and then we moved to C, but we also investigated Rust. So you can actually use the Golang interface to write code in Rust. But as Eduardo said, it ends up not actually, you don't gain a lot. Because you can't work with the concurrency features of Fluent Bit. Like in a way, Fluent Bit kind of like has its own runtime almost. Since in Golang and Rust, you can't really work with those, you don't gain very much. You end up having to, there are other ways that you could also like integrate Rust because you can compile Rust and C together, which we experimented with, but you end up having to use a lot of C objects in the Rust code. And we kind of ultimately decided it didn't really have any strong benefits. It's the sort of thing like if you really love Rust and you just want to write in Rust just because you love it, you could do. But if you're just making it from a purely kind of like pragmatic decision, it didn't really seem to hold enough value.
Cool. And second part of that question, are there future plans for Rust integrations?
As Eduardo said, at the moment, no.
Okay.
I'd say like, especially for us as maintainers, since, you know, Eduardo and Masoud are both, I'd say expert C programmers. I'm maybe more intermediate C programmer. It's easier for us as maintainers to maintain the project if it's only in one language, you know, that's also one of the issues.
Yeah, and one of the questions that we always get is about if we can replace some components with C++, which is happens to be pretty much similar question that for other languages. And at the end, the answer that we gave for Rust was pretty much the same that we did for C++, right? So this is not about which language is better, more secure or weak. It's about a matter of performance. And I think that, to be honest, Fluent Bit is really secure from all the angles. And yeah, so, and we're not saying that it's something that we will not do. I'm saying that this is something that at the moment, there's, well, as Wesley said, there's no much value added to it. But at some point, I think this is beneficial to extend to different mechanisms so people can extend it on different ways. But what happened is that, for example, most of people in the filter side, for example, if they want to add a special logic or complexity to take decisions on how to modify the records, as of now, Lua has been enough, and the performance penalty is pretty low. And in the output side, most of the connector relies on HTTP backend. So write an HTTP output plugin for Fluent Bit is pretty straightforward because we provide all the APIs for networking failures, HTTP client, and everything that is needed to achieve that. And that's why, for example, many companies has implemented their own connectors, mostly sometimes without any external help. For example, the case of Datadog. They just come up and say, hey, we want to write our plugin. They use the API and was really straightforward for them.
Okay, one final question. As I saw in the early days of Fluent Bit docs, it was said that it was designed for embedded devices, for the low resource consumption, etc. Is its focus now on Kubernetes and cloud services?
Okay, the design at the beginning was for embedded devices. So initially, with that statement in mind, it was mostly input and output plugins. There was not filtering at the beginning. And with inputs, I'm referring to, we just offer the plugins to read data from serial interface, memory metrics, CPU metrics, and most, kernel log messages, things that happens inside the device. And in the output side was treasure data output, HTTP, pretty simple. And the traction was mostly seen on the cloud perspective. So we said, hey, we're going to focus in the cloud. But when we say we're going to focus in the cloud, it doesn't mean that we're going to build a big beard, right? That was really heavy. So I think that, yeah, Fluent Bit is now, I would say, cloud focused, because I would say 90% of our users are Kubernetes users, Docker users. But we always keep in mind this mindset of low CPU and memory usage, always. So it doesn't, for us, it doesn't matter where Fluent Bit is, it needs to be optimal. So for us, it can run on a very small ARM CPU, or can run on any big kind of server on any cloud provider. So yes, originally created for embedded devices, for embedded Linux devices, but now it's with a focus on the cloud, but without losing performance and memory. And that's one of the strong reasons also of the language, because managing our own memory, we know how to optimize, we know how to reduce the memory and avoid any kind of issues or performance issues that are mostly generated by garbage collectors languages.
Okay, great. Well, thanks Eduardo, Masoud, and Wesley for a great presentation. I'd also like to thank the attendees for joining. As a reminder, the recording and slides will be up later today on the CNCF webinar page. We look forward to seeing you again for another CNCF webinar. Thanks everyone. Have a great day.
Thank you. Bye-bye.